So welcome to lesson 4 for exponential functions. We're going to continue with power laws today, just a review of what we did last video. Plus, I'm going to teach you a small shortcut. So mine's on activity, definition of powers, and the power laws or exponent laws. So there are 3 power laws. State them in your own words. Use examples if it helps you describe the laws. There are also 3 definitions. We've only looked at 2 so far. I want you to state them in your own words and again, use examples to help you. So pause the video, do this, and then I'll show you what I have as a quick summary of the laws. So I use very little words to describe the laws as well as the definition. So remember the laws are multiplication. If you have 2 powers with the same base being multiplied, copy the base and add the exponents. Division law. If you have 2 powers being divided with the same base, copy the base and subtract the exponents. Power of a power. If you have a power being raised to an exponent, copy the base and multiply the exponents. So those were the 3 power laws. The 2 definitions we've seen so far with powers is a to the power of 0 is 1. So any base to the power of 0 is equal to 1. The second definition we saw was a to the negative b is equal to 1 over a to the positive b. So whenever you have a negative exponent, you can convert it to a positive exponent by making a fraction where the numerator is always 1, and the denominator is essentially this power, but with a positive exponent instead. The third law, I'm going to write pending. Oh, sorry, not the third law. The third definition is pending. We're going to look at that in our next lesson. So before we move on, we know the power laws, we know most of the definitions of powers. There is a shortcut that I wanted to show you. This is converting negative exponents to positive ones as well, but it involves when your base is a fraction. So it's called the flip it rule. It says when a fraction is raised to a negative exponent, what you want to do is flip the numerator and denominator. Oh my gosh, what am I writing? Denominate. Okay, let me just start that again. Okay, so the numerator and the denominator, and change the exponent to its positive form. So in other words, you're finding the reciprocal of the fraction, and when you do that, the exponent changes from a negative to a positive. So I want to show you that this actually works. So let's take a look at this particular fraction raised to an exponent, a negative exponent, and let's follow the definition of powers to solve this, and then let's use the flip it rule. So if I use the definition of a power, I know that if I have a negative exponent, I can convert it to a positive exponent by doing 1 over this entire expression, where the exponent is now positive. So instead of -2, it's +2. I can rewrite this as 1 divided by 2 over 3 squared. If I keep simplifying this, I have 1 divided by 2 over 3 squared. Remember, is the same thing as 2 over 3 times 2 over 3, which is 4 over 9. Here I have 2 fractions that are being divided by each other, so I'm going to rewrite it as a multiplication question where I take the reciprocal of the second fraction, and now I can multiply it out. 1 times 9 is 9, and 1 times 4 is 4. So using the definition of powers, I can easily solve this. That's fine. We can use the flip it rule, which makes our lives so much easier. How do we know we can use a flip it rule here? Well, there's 2 conditions that need to be met. The first one is you need to have a fraction. And the second thing is you need to have a negative exponent. So I have a fraction as my base. Great, I have a negative exponent. So what the flip it rule tells me to do is to flip the numerator and denominator. So 2 and 3 will flip. So instead of 2 on the top, it'll be at the bottom. And instead of 3 on the bottom, it'll be at the top. And when I flip around the fraction, this exponent goes from negative to positive. So now I have 3 over 2 squared, which is the same thing as 3 over 2 times 3 over 2, which equals 3 times 3, 9, over 2 times 2, 4. So you'll end up with the same answer whether you use the definition of powers or the flip it rule, but clearly the flip it rule is meant to be short, concise, and get you to your answer faster. So evaluate the following powers using the flip it rule. Again, make sure that you can use the flip it rule. So the two conditions again are you have a fraction and it's being raised to a negative exponent. Here I have a fraction, it's being raised to a negative exponent. So what I'm going to do is I'm going to flip it. Flip the numerator and denominator. So the 4 and 3 swap places. And when I flip it, the negative exponent becomes positive. So I have 4 over 3 to the power of 3. Again, I'm going to use power laws to help me solve this. So remember, this is the same thing as saying 4 to the power of 1 divided by 3 to the power of 1, all to the power of 3. So because I'm raising powers to another exponent, I'll copy the base 4 and multiply the exponents. 1 times 3 is 3. And here I'll copy the base 3. Again, I'm raising a power to an exponent, so I do 1 times 3, which is 3. So 4 to the power of 3 is 64, and 3 to the power of 3 is 20. Sorry, I'm just trying to flip this. 27. Again, if you can do this in your head, and you can go straight from 4 over 3 to the power of 3 is 64 over 27, do that. That's even better. Again, let's see if I can use the flip it rule for the second question. I have a fraction. It's being raised to a negative exponent, so it works. What I want to do is flip the numerator and denominator, so that'll give me 3 over 1, and that changes the exponent from negative to positive, which is 4. I know 3 over 1 is the same thing as 3, so I have 3 to the power of 4, which is 81. Again, these are numbers that I said you should become more familiar with as you practice doing these questions. The last example here, again, I have a fraction, a negative exponent, so I can flip the fraction around. 3 over 2 becomes 2 over 3, and the negative 1 becomes a positive 1. Well, 2 over 3 to the power of 1 is just 2 over 3. So whenever you see a fraction being raised to a negative exponent, feel free to use this flip it rule to make your life easier. Give me 2 seconds as I switch to the next page. So really the flip it rule was the only new material for this section. What we're going to do is we're just going to keep practicing our power laws. So let's start with this question. It says, exercise, simplify the following expressions as a single power and then evaluate. So again, we need to write it all as a single concise power, and then I'm going to solve or actually figure out what that power is equal to. So let's take a look here. I have 3 powers, all with the base of 2, and they're being multiplied here and divided here. As I mentioned in the last class, we can do this all in one step. So what we can do is we can say 2, because these powers are being multiplied, keep the base 2 and add the exponents. So I have negative 4 plus negative 2. And then I'm going to divide by 2 to the power of negative 6. So when I'm dividing, I'm going to subtract the exponent. So minus the minus 6. Again, don't forget to include both of these minuses. This minus takes care of the division. This was a negative 6, so copy it as is. I can simplify here. So 2, this is the same thing as saying negative 4. A positive and a negative will give me negative 2. So negative 4 and negative 2, there are 2 negatives here. That'll be a positive 6. So this is 2 to the power of negative 4, negative 2 is negative 6, plus 6 is just 0. And so 2 to the 1, again, based on the definition of powers, anything to the power of 0 is equal to 1. So what does that really mean? That just means this is just a fun, fancy way of writing 1. It's equivalent to 1. Let's take a look here. So here we have a fraction being raised to a negative exponent. We can use the flip it rule here But what you'll notice is that we can simplify the fraction anyway. So if you can simplify stuff, start by simplifying things. So within this fraction, I have 2 to the power of 4 divided by 2 to the power of 6. When I'm dividing powers, I'm going to keep the base, and then I need to subtract the exponent. So 4 minus 6 is -2. And I'm going to copy the -3 because I haven't touched that yet. Then I keep going. I have a power here being raised to an exponent. So I'm going to copy the base and multiply the exponents. -2 times -3 is +6. So I've expressed it as a single power. Now I need to solve. Okay, so 2 to the power of 6 is 2 times 2 times 2 times 2 times 2 times 2. And so again, you need to become familiar with these numbers. 2 to the 4 is 16. So 2 to the 5 is twice that, 32. And 2 to the 6 is 64. So you should know that this is 64, and really you should know that off the top of your head. Moving on to this question, I have a whole bunch of things. Again, I have brackets and brackets. We like to get rid of those brackets first. So let's take a look here. I have a power being raised to another exponent. So I'm going to copy the base, -7. And because I have two exponents and I'm raising a power to an exponent, I'm going to multiply them. So 2 times -2 is -4, divided by -7 over -3. So again, what I see here is two powers being divided and they have the same base. So I'm going to copy down the base, -7. And because it's a division, I'm going to subtract the exponents. So this is the same thing as saying -4 minus, which is for the division, -3. So don't forget those situations where there is a double negative. So this is the same thing as saying -4 plus 3. So -7 to the power of -4 plus 3, which is equal to -1. So technically, we have expressed this as a power, as a single power, but something I want you to keep in mind is whenever we're expressing things as a single power, our exponent should always be positive. Exponent is negative here, which we don't like, so let's use the definition, one of the definitions of the exponents to convert it to a positive exponent. So here I have a negative exponent and I don't have a fraction. So what I'm going to do is I'm going to change this so that it is a fraction. Remember, the numerator will be 1 over -7 to the power of +1 in this case. And that's equivalent to -1 over 7. So the 1 stays and -7 to the power of 1 is just -7. Let's keep going. There's 2 more examples and then 1 more set of questions. So here again, I have brackets and fractions. I can simplify these brackets, and that's what you want to always start with. So here I have a division of powers. Keep in mind that the 10 is lonely, but really it's 10 to the power of 1. So when I'm dividing these powers, I need to subtract the exponents. So I have 10 to the power of 1 minus -2. So the minus takes care of the division, and I'm copying the -2 as is. And I'm going to put that to the power of 3 because we haven't touched that yet. And in this bracket, I have 10 to the 5 divided by 10 to the 10. So again, copy the base and subtract the exponents. So what I'm left with in this bracket is 10 to the power of 1 minus -2 is just 1 plus 2. So 10 to the 3 to the power of 3. And here 10 to the 5 minus 10, which is -5. I can keep going because it's still not a single power. So here I have 10 to the power of 3, all to the power of 3. So I have a power raised to an exponent. So I'm going to copy the base and multiply the exponents. 3 times 3 is 9. And I'm going to just copy this as is because I haven't touched it yet. Again, I still don't have a single power, so I'm going to keep going. Here I'm multiplying powers, so I keep the base and I add the exponents. 9 plus -5, or 9 minus 5, is just 4. So I've written it as a single exponent. It has a positive, single power. It has a positive exponent, which is great. Now I need to evaluate. Remember the shortcut I taught you yesterday when you have 10 to the power of something, copy the 1 and write this many zeros. So 4 zeros, 0, 0, 0, 0 gives us 10,000. The next example here, we did something similar yesterday. So at the top, we have a multiplication of powers. So I'm going to copy the base and add the exponents. So -4 plus -7 is the same thing as saying -4, -7, which is -11. So I have -11 at the top. In the bottom, I have power being raised to an exponent, so 2 to the 4 being raised to -2. So I copy the base and multiply the exponents. 4 times -2 is -8. I still don't have a single power, so I'm going to keep going. Here, I have a division of powers, so I'm going to copy the base again, but I'm going to subtract the exponents. So -11 minus, the minus takes care of the division, -8. So here, minus and minus become plus. So I have 2 to the power of -11 plus 8, which is just -3. Now you should notice that, yes, this is a single power, but we don't like it because the exponent is negative. So using the definition of powers, we can change this. This is the same thing as 1 over 2 to the power of 3. And now we can solve for it, or solve it. This is 1 over 2 to the power of 3 is just 8. Okay, so what this exercise was meant to show you was pretty much this. The power laws can be applied to powers with negative and zero exponents. Essentially, you're always using all 3 definitions of the powers and all 3 power laws in order to evaluate and simplify these questions. The last example I want to show you is this. So evaluate the following expressions. Determine when you can use the power laws. So one major mistake a lot of people make is using the power laws when you cannot use them. Again, power laws, they're pretty clear. You can use them when powers are being multiplied with the same base, when powers are being divided with the same base, and when you have a power being raised to another exponent. If you don't have these situations, you cannot use the power laws. So let's take a look here. We have 2 to the -3 plus 4 to the 0 minus 2 to the -4. I see these have the same bases, which is great, but I'm not multiplying or dividing them, so I don't have power laws to help me here. When you don't have power laws, go with the definitions of powers and see if you can simplify as much as possible. So 2 to the -3 is the same thing as 1 over 2 to the 3. That's one of the definitions of a power. Plus 4 to the 0 is just 1. We know that that's another definition. Anything to the power of 0 is 1. Minus 2 to the power of -4. Again, that can be rewritten as 1 over 2 to the 4. So yes, using those rules, we were able to simplify stuff, but now we need to keep solving it. So 1 over 2 to the 3 is just 1 over 8, plus 1 minus 1 over 2 to the 4 is 16. I have an addition of fractions. I need to find a common denominator. The common denominator here is 16. So let me just grab another color. So to go from 8 to 16, I need to multiply by 2. So I need to multiply the top by 2 as well. So 1 over 8 is the same thing as 2 over 16. Plus here, 1 is just 1 over 1. So that's just 16 over 16 because I multiplied both the top and the bottom by 16. And here, the third term already has 16 as its base, denominator. So I'm going to write it down. So now I have 2 over 16 plus 16 over 16 minus 1 over 16. When I'm adding or subtracting fractions, I keep the denominator and just add or subtract the top. So 2 plus 16, 18, minus 1 is 17. Again, don't forget to see if you can simplify the final answer at the end. In this case, we cannot. We look at this. Here we have 2 powers being added. There are no power laws with added. with addition, but what we see here is we have fractions being raised to negative exponents. So we look at this and we're like, great, we can use that flip it rule. So here I have a fraction being raised to a negative exponent, so I flip the numerator and denominator. So when I flip 1 and 2, I get 2 over 1, which is the same thing as 2. But when I make that flip, the negative exponent becomes positive. Plus, again, I have another fraction being raised to a negative exponent. So I'm going to use the flip it rule. 1 over 3 flipped becomes 3 over 1, which is just 3. And the negative exponent becomes positive. So at the end, this just becomes 2 to the 1, which is 2, plus 3 to the 1, which is 3. So 2 plus 3 is 5. Let's take a look at this last question. So here I see some negative exponents. I see 0 exponents. So let me use some of those definitions. I'm going to copy the 25 because I'm not doing anything to that right now. 5 to the negative 1 is the same thing as 1 over 5 to the 1, plus anything to the power of 0 is just 1. So I have 25, 1 over 5 plus 1 as my simplified version. Here I see an addition of fractions. So I can start with that. When I want to add fractions, again, I need a common denominator. The common denominator here is 5. So to get to that, I'm going to multiply both the top and bottom by 5. This simplifies to 25. Again, when I'm adding fractions, keep the denominator and add the top. So 25 times 6 over 5. Now we're multiplying fractions, which means we can simplify. I can't simplify this way. I can't simplify this way, but I can simplify diagonally. I can divide both of these by 5. So 25 divided by 5 is 5, and 5 divided by 5 is 1. So I have 5 times 6, 30, divided by 1 times 1, 1, which is just 30. So the homework you have then is page 407, number 1 to 9 and 11. Again, most of the past 2 lessons should have been reviewed. Really, the flip it rule is the only new thing you should have learned. Thank you.